Hello everybody. What I want to do in part 2 of this video is to put mathematical values on our relationships that we showed in part 1, the correct relationship between light, matter, space and time. There's one mathematical expression in which we can encompass all of these and put a value on it. Now we saw in part 1 that nothing can have a state of being as an individual quantity or a unit. It must be a complementary pair. And that the whole of reality can only be described as physics, or the physical, and the non-physical, what's outside this magnet, the virtual particles, which can only be described mathematically, the imaginary numbers, which don't have individual units, space, uncountable, no units, matter and light, photons and real particles comes in units. And there's a relationship between them. There's a lot more space than matter and light, but it's just concentrated. When I concentrate energy, negative energy, the two parts of negative energy that make electric magnetic fields and gravitational fields, if I concentrate them, I get light. If I concentrate energy, I get matter. But it's all the same. If I add it all up, it's the same. And now we're going to put a value onto it. Now, we saw that everything must be described as 2. Now, we described space, light and matter as virtual and real, but energy itself, I can describe them all as parts of energy, negative energy, positive energy. The energy must be described as a complementary partner that shows up in reality. Now if you think, when we have the Big Bang, it's all energy, but it cools down. It cools down into something. And that is reflected in what you see in water. When it's water vapor, lots of energy, like this. It's unstructured, but as it cools, becomes more structured, becomes a raindrop, a unit, a bit, and then it becomes a snowflake, very, very structured. It's mathematical. Bit, qubits, it's information. So let's write that in here. Information is the complementary partner of energy. Now let's see that in reality. If I look at the cell, I've got 2 different systems. There are only 2 different kinds of systems. Systems in which we have the flow of energy, that's the biology of the system, and systems in which we have the flow of information. That's the DNA, genetic. So that's what's happening here, my evolution. As I start at the Big Bang, it's cooling down and I'm getting more and more bits of information. I'm changing energy into information. So my minus changing into a plus. Now, that gives me a solution as to what the Big Bang is, what banged, and why it banged. Because there must be an inverse for all of this. Can't have anything by itself. And we know, without doubt, you cannot create the real parts of matter here unless you create an equal amount of its inverse, antimatter. Now that means that the universe must have two parts, a mirrorverse, where all the rules and laws are exactly the same, except one. Matter and antimatter both have positive mass. That means they attract each other. We saw yesterday that energy holds space together, and space holds energy together, each one affecting the other. But if I've cooled my universe down here so that all my energy has gone and I've just got matter and gravitational force, it's all cooled down, there's no energy left. If I bring this matter and my mirrorverse matter back together, it changes all my information into energy. So entropy starts again going from positive to negative. So there's evolution, there's entropy, and they only have to meet back up. And there are plenty of shapes, 3D shapes, that show how these can meet back up. And if you remember that the energy in space is holding that space together in a shape, and the shape is holding the energy together in stars and planets and galaxies. Imagine two Klein bottles feeding back into each other. That gives me a solution which I can understand. So now I can see that I've got a sensible universe. And it's all based on my little algorithm of two inverse partners and an opposite. Now, this is complex. I've got my simplicities here, my dualities, which we described in part 1, that creates just elements and stars. Everything, all the dualities are simple. They sit underneath the complexities. That's what music is. It's simple. Dualities, harmony, rhythm, major, minor, and animals use it as language because it's simple. Language is complex and made of 3 parts: signs, meaning, and code. So there's my simple computer, a binary computer that flips over into a complex computer which has 3 parts. Now all complex systems show the same thing. I've got inverse partners and an opposite, and that generates the complexity that we see outside. I can quantify systems. So I've got 2 parts of physics and the mathematics of complexity and systems. The only thing I can quantify is where these bifurcations take place and the size ratios of the bifurcations. I can't quantify anything else. So individual human behavior, I can't quantify it. But collective behavior, I can say, is going to go in and out of ordered and disordered behavior just the same as this. Now these quantities are both based upon a ratio, which statically we call the correct ratio between asymmetry and symmetry. That's the golden ratio. And this is the golden ratio being used dynamically because both the values that quantify the bifurcations and the size scaling ratio, the self-similarities, are based upon the golden ratio. But here they are dynamic. So now I've got something that I can make sense of. A simple binary computer which goes into a complex computer which has chemistry, which changes into viruses and biology. Complex computer, binary computer, all acting together to bring more and more bits, units and qubits into the universe. It is a computer. So let's put some values on that. So I've got energy changing into information. My quantities, physics, I quantify things. But the qualities, the forces, the interactions, I've always got something in between quantities, which we call the ratios, or the constants of nature. The fine structure constant, which sits in between strong nuclear force and electromagnetism, and that tells things what to behave as, how to behave. Here, a quantity, behave as this, quality, how to behave. This is what we want to quantify. The unquantifiable space, quantities, then matter and light with quantities. So I'm going to put some ratios on here. So if I go back to my numbers that build everything, there must be numbers underneath, which is simple, and there are primary numbers. The relationship between 2, 3, symmetry and asymmetry. Now there's my first two prime numbers, which must behave the same as atoms. I don't get units to start off with. 2 is the first number, and it must behave the same as this, and bifurcate to give me the other numbers. Well, there are two ways that I can bifurcate 2. I can have +1 and +1, but in order to satisfy quantum rules, there must be other aspects of these +1s which are different. And I can bifurcate into -1 and +1, and what I see there is the nucleus of the helium atom. I've got 2 neutrons, 2 protons, but they must spin in opposite directions to satisfy quantum rules. And I've got a relationship between the neutrons and protons, and the protons which have a relationship with the electromagnetic force. So that is the helium nuclei, showing you that numbers and atoms are the same thing. So I've got my relationship between the prime numbers and the numbers that they build, the composites. And I'm going to show you that this can all be explained by this relationship between the uncountable parts, the space, and the countable parts, which must come 1, 2, 3, 4, 5, 6. I must have 6 to get complex protons and neutrons, complexity, not just the 3. I need to bifurcate it into 6. So I'm going to use the zeta function. Euler showed has a relationship between the primes and the composites. And what he did, primes build all the composites. There's a unique way in which you can build each counting number using primes. What Euler does, he shows that if you take the counting numbers, if you square, or take the reciprocal of the square, the composite numbers, put that as an infinite series, what you get is pi squared over 6. If you take the primes and square them, and put that number over 1 less than the square, you also get pi squared over 6. This is a relationship between random and order. Now this is also the relationship that you see in the compound eye, the relationship that shows why hexagons, bits you can count, and spheres and circles, bits you can't count, fit together. Now, we've got 2 parts of time, evolution and entropy, which must be equal. Noether's principle, Emily Noether, who wrote Noether's principle, shows that the time is homogeneous. The 2 parts are equal value. What I see almost equal to e to the half, which is the same as e, root e, the 2 roots of time almost equal to. I mustn't have symmetry down at the base, where everything just disappears. I must have almost equal to the ratio between what is countable, light and matter, and what's not countable, virtual particles that make space, almost equal. So you can see here, I've just got relationships, the 2 parts of time in an equal relationship, and space and energy, positive energy, negative energy, positive energy. So that's plus, that's minus. I've also got time plus and minus. So I've got like a little matrix, and you'll see reflected in that little matrix the Dirac equation, which isn't as yet unsolved, but there's a solution. So let's put a value on the quantities we find in the universe, the qualities, the interactions, and the two parts of time. Now, pi squared over 6, 1.65. What I can measure and what I can't measure. I can only describe its qualities. And the two parts of time. Time plus time minus 1.65, 1.65. So here we have a little mathematical expression that describes how the whole universe works. Simple enough to put on a t-shirt. Now, we have to test and test and test everything that we do in science. I'm not just pulling all this out of thin air. There are mountains and mountains of papers and information which have come out of this, and they've all been peer reviewed by professors and people who can understand all this stuff here in Taiwan. They've been going through it for about 3 years, again and again and again, to look for any problems, but they couldn't find any. So all we've done here is give a description of reality, which is the same as what we observe. Now, physics is validated by mathematics. You predict the result of an experiment, and you do the experiment, you measure it. But mathematics is validated by the philosophy of language. I cannot have any contradiction. So it's the axioms of language which are laid down in Euclid's Elements which validate the mathematics. So it's the philosophy which validates the mathematics, and it's the philosophy that we've all had wrong. But we have no chance, because until you have computers to find these strange geometries, it's impossible. You would never imagine that something like turbulence in a fluid electrical circuit of populations of rabbits and foxes would all be connected by the same mathematics, until you can actually measure those systems empirically. So that's been the problem all along, just lack of information. But then when you get the information, you've got too much information, huge amounts of information to go through, to validate this, to see it's all just a jigsaw that fits together, everything just using the same principle. So there's the physics, but the mathematics is defined as quantities, space, qualities, and change. Exactly the same. I can't measure space, like see what effect it has, or an electrical field or a magnetic field. I can see what it does, but I can't measure it in real numbers. I have to use virtual numbers. Now you've all accepted this because you can see it. So we've had the same problem all the way through history, when we find 0, and then negative numbers, and then imaginary numbers. There's an acceptance period. Now we're just asking you to do the same thing again, to accept that all the virtual parts of reality, which can all be explained using mathematics, are as real as everything else. You can see what they do, so you know that it's part of reality. It's the same reality, just becoming more and more ethereal. So 0, look at 0, that must have 2 answers. And it does. It's both everything and nothing at the same time. Because if I take all my positive and negative particles, if I add them all together, the entire universe in positive and negative particles, everything turns out to be nothing. So I've got 2 different zeros. One that tells me there's nothing there, or it's different from this, I don't have electromagnetism, I've got a strong weak nuclear force. I've got the opposite, or I've got the inverse. Infinity. It's not just infinity by itself, it's a mixture of the finite and the infinite. So imagine if I'm walking on a circle. I can stop when it's finite, I can always take another step towards my own back without getting there. Infinity can't be an end result which is finite by definition. So you see how you can use this to clear up all the mess that we've been living with. Well, it's very, very easy once you get this to just look at the mathematics that we get in chemistry, which is static, flipping over into the complex mathematics of systems inside cells. And I'm going to see that in biology I get the same here. Now we start with cells, which is just a relationship between energy, forces, and elements. But when that becomes bigger, I'm going to get the physical parts of biology. Now we've known for a long time that respiration and photosynthesis are the inverse process of each other. They're both composite, positive time. So there must be physical life up here which is decomposite. And the opposite of these two. Now I'm going to let you work that one out for yourself. See you next time. Bye bye now.